Hi everyone, my name is Alik Talipov and I'm the host of our today's workshop. And today we will be speaking about the stacks together with our friend and colleague Vetle Stubberud. But before we start, I just want to make a couple of reminders and news. And if you're new here, we are kind of a community and think tank of blockchain enthusiasts and engineers who are interested in blockchain and in its early adoption. And we also have many other interesting activities within our community, such as conferences, podcasts, articles, blogs, and so on. So the next big event is the Blockchain Community Day, which will happen on June 5th until June 9th, fully online and free. So please join our conference, visit our website, subscribe to our social media, and you will be invited and you'll get all the news about our future activities. So without further ado, I'm going to invite Vetle. Hi Vetle, how are you?
Hello, I'm fine.
Yeah, thank you for being with us. And now I'm going to bring your presentation to the stage, and I hope you see it fine, right?
Yes, I can see it.
Okay, then, good luck, Vetle. Thank you so much. And before we start, just a quick reminder that if you will have any questions, just leave them in the live chat on YouTube, and we will get back to them at the end of this session.
Yep. Let me find everything. Yeah, so today we're going to have a short or semi-short workshop on the Stacks network. And I assume most of you are not too familiar with the Stacks network. So don't worry, we're going to go over everything, how it works, the different apps on it. And then at the end, we're going to do some live coding or semi-live coding, just introducing you to all the tools that are involved in the Stacks network. And yeah, so the agenda for today, first, we're going to have a quick overview of Stacks, the network, how it works, when it was created, etc., etc. The second one, we're going to have present the whole ecosystem for Stacks, the different apps that are being developed, and also these sort of new inventions that are being made in the last couple of months, mainly in relation to BRC20 and ordinals. After that, like a deep dive into the Clarity language, which is the smart contract language for Stacks. It's the language we use for developing smart contracts and applications on the Stacks network. And then at the end, we're going to have a short workshop where we're going to interact with Stacks using Clarity. So we're going to look at a smart contract, look at how it works, and then hopefully try to deploy it to the network. Hope it will work. Sometimes it's a bit slow, so let's see. Okay, how do I go to the next slide, Alec? Can I do?
Do you see the arrows when you try to? So, does your mouse work collaborate with the presentation?
No, I don't think it does.
Okay, you can say me to switch to the next slide, or we can try to share your presentation on your side.
Okay, you can do the next slide. I can just tell you when it's in the next slide. I will just say next slide. Okay.
Okay. Yeah.
Mm-hmm. Okay. Yeah. So now we can go to the next slide. Yeah. So a quick overview of the Stacks networks. It's an open source network. It's not which is quite a large point. Most of the blockchains are. They have three different structures, basically. They're DAOs, open source, or they're private. So, and something like Solana, for example, completely private. DAOs, which I will not go too much into here, is more like a democratic structure where people own tokens and then they do development on the blockchain for rewards or incentives. And an open source network is more like you have a GitHub repository. People can, commit to the code. Everything is open, at least the parts that can be open, which is the way that Stacks has kind of made their network. And yeah, Stacks allows for the app development on the Bitcoin blockchain. It doesn't mean that you're directly committing code to the Bitcoin blockchain, but you're committing code to a layer 2, which is a blockchain that kind of, it lays on top of the main blockchain, as you can see in the image. We have, for example, Ethereum and Matic or Polygon, where Ethereum is the base layer and Matic kind of interacts with Ethereum and synchronizes with the blockchain, but they're not making direct commitments to the chain itself. It's just synchronizing with the main chain, acting as a layer on top that kind of uses it to store the information at regular intervals or synchronize with it. And yeah, it was created in 2003 as a research project in 2013, but it took off in 2017 when the tokens were introduced. In the beginning, it wasn't really stacks. It was more of like, how can we make Bitcoin like provide yield, or how can we make something more with Bitcoin? Because basically the way Bitcoin works is a pretty slow and boring chain. You do peer-to-peer transfers, you save your money. There's no like smart contract interaction, nothing really sophisticated about it. In relation to Ethereum, you can do a lot more things with the chain. You can automate things, create all these decentralized applications, DeFi platforms, DEXs, all these different type of new inventions sort of that came with Ethereum. Bitcoin doesn't have, because it was the first one. So Stacks is sort of a way to try to take that concept of decentralized finance and put it onto the Bitcoin blockchain. Next slide. Yeah, and so how this works in terms of the consensus itself. Consensus is one of the most important parts with the blockchain. You need some way because there is no centralized entity that controls this and everything is open, you need someone to kind of agree on how the data should be stored, who can access the data, when the data can be publicly available, when it's finalized, all these different things. So for Bitcoin, and the first one and the most popular one used in most blockchain is proof of work. Very simple. You have miners that kind of commit their resources to the blockchain by solving some random puzzles, and they get rewards for solving those random puzzles. And if someone wants to, do a DDoS attack on the whole blockchain, they would have to take down all the individual miners, which is not usually, or at least for a network like Bitcoin, it's not possible, because the amount of computing power you would need to kill all the miners or beat all the miners is not something an entity would be able to acquire. Proof of burn is a different mechanism. Some blockchains use this one as well. It's basically a way where you send tokens to a miner, sends tokens, and then you receive kind of like you receive a consensus by them burning tokens, by sending it to some pool, some wallet, some mechanism that burns tokens from the network. So you have an anti-inflation connected to it as well. And yeah, that's the two ways that Stack is kind of built on. It's built on proof of work and proof of burn, and we have a hybrid of that, which is called POX, that I will be introducing in the next slide. Now to the next slide, yes. So POX, the way that it works is you have the miners, and the miners send, or you have two concepts. You have miners and stackers. So the stackers, they stack their coins for rewards. The miners, they send their Bitcoin to the stack chain or to a burn wallet in order for the for the stackers to get the reward for it. And there's an even distribution. So miners, depending on how many Bitcoin they want to send to the stackers to burn or to convert to stacks, they will get rewarded in a more equal fashion. So for example, if you have 100% of the newly made blocks Bitcoin that are being burned, you're going to get 100% of the rewards as a miner, and the same distribution happens for the stacker. So the stacker stacks their stack. If you're 100%, you're the person who stacks 100% for the next block, you're going to get 100% rewards. And that's kind of how it works. The miner gets rewarded in Bitcoin, and the stackers get rewarded in stacks. This, in relation between what you get rewarded in, can depend a bit on how the network is doing. But generally speaking, miners get rewarded in the currency they provide in, and stackers get provided in the currency they provide in. And yeah, that's how it works. Okay, next slide. And yeah, for the applications and ecosystem for Stacks, so there's three main actors that are quite important for the Stacks network. There's Stacks itself, there is Hero, and then there is a company called Trust Machines, and they do three different things for the network. So Trust Machine is kind of like the incubator where they provide the funding to the projects and they have the staff. Hero is the development project itself, where they develop all the applications. Hero Wallet, all the things where we're going to look at later, where we're deploying the smart contracts that are made by Hero. Trust Machine is the incubator, and Stacks is the network itself. And they don't necessarily have anything to do. They don't necessarily only deal with Stacks. They deal with the Bitcoin system in general. Because as we will see in a bit later, there are several inventions that are outside of only stacks that are related to the Bitcoin network or to trying to make a DeFi system on top of Bitcoin that they deal with. But most of the applications that they have currently funded in the last couple of years are related to stacks. It's only newly that there's more inventions that are kind of, or more projects that are becoming DeFi focused outside of stacks. And for most of the projects on Stack, they focus on providing yield to Bitcoin holders in some form of reward, equity, or cashback. The main reason for this is that, or the idea of the Stacks team is that Bitcoin is the biggest sort of currency and the most stable and safest currency in the crypto kind of ecosystem or crypto sphere. And so when big investment banks or big clients or any kind of venture fund wants to get into crypto, they're going to buy Bitcoin first. But Bitcoin is not that attractive for them because there's no yield. It's just holding the currency, hoping that it goes up. There's not much you can do with it, right? So it's kind of like a boring currency like gold. And generally speaking, these institutions are not that interested in very boring assets that don't provide any equity or any reward. And so by their idea is that by making Bitcoin provide some kind of yield, it will make it more attractive for the investors to get in on the Bitcoin train, and then eventually that kind of trickles down to other cryptos, and you have all the bigger banks getting into crypto in this way, which is kind of true. The last couple of years, we've seen a lot of banks that are issuing kind of these derivative crypto contracts, but they're mainly focused on Bitcoin. I think there's one on Ethereum, but there's not that many. So yeah, they're first getting into Bitcoin, many of them, and then maybe also stable coins to some extent. And yeah, for the last couple of months, the network has seen a huge influx of new users due to the ordinals and BRC tokens that are being created. The growth just in March, which was 2 months ago, was 23%, which is I think it was the largest increase of any blockchain at that time. And this doesn't only go for the Stacks network. This goes for any kind of token that has to do anything with Bitcoin and making tokens on top of it, trying to make Bitcoin decentralized or a DeFi application, basically. But Stacks is the biggest one of them, so it had the biggest influx. Okay, next slide. And yeah, for these ordinals and also these BRC things that I talked about in the last slide, many probably don't have any clue what that is because it's a very, very new thing. But basically, ordinals is an NFT that you inscribe on Bitcoin. So people figured it would be a good idea to, NFTs wasn't fun enough when it was also on Ethereum. Let's bring it to Bitcoin and let's try to make it infinite, or make it so that we can store it for infinity on Bitcoin. Because if you're using a layer 2, you're reliant on that layer being always maintained. That is kind of, you always have the miners. But if you inscribe it directly on the Bitcoin blockchain, you know that, okay, Bitcoin is always here. Probably it's never going to go away. So our NFTs will always be a thing. In the beginning, this was a huge problem for the network. It actually made it so Binance couldn't withdraw any Bitcoin for a couple of days because there was so many people trying to inscribe their NFTs on Bitcoin. So how good it is for the network, I don't know, but it's kind of like a new invention at least. And ERC20 is just the equivalent of ERC20, but for Bitcoin. So ERC20 is basically the tokenomics way of making a token for Ethereum, and ERC20 is the way of making a token for Bitcoin. So they're the exact same thing, just different blockchains. ERC20 doesn't necessarily need to be made on Stacks. It can be made on the Bitcoin blockchain itself, but yeah, there's different ways of doing it, different derivatives. The easier way to make it is by being involved with Stacks to begin with, and then kind of trickling it down to Bitcoin, not making it directly on Bitcoin, because as I said with the NFTs, it's extremely resource inefficient to inscribe something on Bitcoin. I took down the whole network when I tried to do it with NFTs. So usually a hybrid where you have a layer 2 that kind of does some operation with Bitcoin and stores an artifact is like the preferred way for people. And yeah, Hero itself, so one of the big companies involved or behind Stacks, maintains Ordinals API and Gamma. Ordinals API is the most used, at least for last month's API to kind of interact with Ordinals, retrieve information about them, etc. And Gamma is the most used NFT platform for both Ordinals and Bitcoin NFTs in general. Okay, next slide. And yeah, and now we will go into more of the technical details around Stacks. I hope the overview was okay and you sort of understand what the network is, layer 2 on top of Bitcoin, tries to make DeFi, etc. So for Solidity, or for Ethereum, you have a language called Solidity, which is the language they write in order to make contracts and deploy them to Ethereum. For Stacks, you have a language called Clarity Lang. And yeah, it's a special, or it's a not a special, it's a specific language created for the sole purpose of deploying smart contracts to Stacks. And you might have questions like, why do you need a new language? Because we have so many languages already, why are we creating another programming language? And the main reason for this is more to do with it's a very specific thing when you're creating smart contracts for a blockchain. It doesn't really, like most of the programming languages we have today, they are kind of made for this model of having a database client, all these different layers. Whereas when you're working with a blockchain, some of these domain-specific things don't work in the same way as they would with a normal program or a programming language outside of the blockchain world, kind of. So there are some things that are domain-specific that these languages do a bit better. That was also the reason why we made Solidity to begin with. The reason they made a new language and didn't choose to go with Solidity or Rust or some of the languages that we will see later on is that they needed it to be one for the crypto domain, for the blockchain domain, and they need to be secure, predictable, and have properties that wouldn't allow for all these hacks that we've seen in crypto in the recent years. So that's why initially Clarity Lang was created, because it was created kind of before Solidity took off a bit. So they started seeing all these issues coming up with Solidity and how you would have overflows, underflows, all these strange bugs that would be appearing. And if you've studied Solidity or you worked some with Solidity, you would know what I mean, especially related to the overflows. There's a lot of different hacks that can be made just by simple, arithmetics in a contract. And that's something that they wanted to avoid. So there's no underflow, there's no overflow. Everything is declarative, interpreted. You know what is happening before your contract compiles, basically. So they're avoiding a lot of the very common pitfalls that the Solidity language sort of historically has had issues with. And up to this date, I don't think there's been a single hack, or at least big hack, related to the Clarity language. Whereas, if you look at Solidity, there's a new one every month almost. Of course, it's a lot more used, so it's not a completely fair comparison. But I think in general, the language is safer. Okay, and then next slide. And comparing it to some of the other languages that I talked about in the last slide. So I picked some of the biggest ones. For Ethereum, we're using Solidity. For Solana, we're using Rust. For Nair, we're using Rust and then a whole skew of sort of cross-compiled languages, Wasm, TypeScript, C++, etc. And so Clarity is more similar to Lisp, which means that it's not like one of the biggest issues when you're sort of getting developers to use your smart contract language or getting your developers to develop on your blockchain is that you need developers that know the language of the blockchain in order to develop. So a lot of these companies have had great success with using Solidity because it's extremely similar to JavaScript and C++. It takes very little time for people to get into. You have a JavaScript developer, you put him through a bootcamp for 2 months, and then he comes out on the other end and can write Solidity. But the main problem with that, again, is that you can put him to 2 months of bootcamp, but then at the end he still manages to have all these security flaws that he has to take into account, and so the curve of learning is quite a lot higher than just learning the language. But that's the main reason that Stacks has tried to kind of make their language more similar to Lisp, which is a language a lot of people have used, at least in academia. It's a bit simplified Lisp, which makes it it's kind of relatable. If you've used Lisp in school, used languages that are similar to Lisp with all these curly braces. If you haven't before, it will still be relatively easy to get into because it's not an extremely complicated language. There's not a lot of weird garbage collection properties or things you have to consider. But then, for Solana and Nair, the natural choice for them was Rust, which is kind of it's in some ways the reasons that they're using Rust is similar to the reasons that Stacks uses Clarity. It's more safe in terms of the security aspects. It's also functional, and it's easier to know what happens. There's not all these side effects that you would have with Solidity, which is kind of like something that we're seeing with a lot of the newer blockchains. They're all starting to use languages that are more type safe and easier to deal with, basically, because for the security reasons. So next slide. Yeah, so for developer tooling, we have Stacks.js. This is the original that I wanted to make the presentation about originally. It's a JavaScript API where you can interact with different stacks, different things in the Stacks blockchain, CLI, contract storage, Hero wallet. You can integrate with Hero, so that Hero wallet, which is Hero is the same as MetaMask basically. Hero will authenticate your users, do different things with you. The same things that you could do with a MetaMask library or use the app library or Web3 library that Ethereum has basically. Next slide. Clarinet, and then there's Clarinet, which Clarinet is kind of an environment for developing smart contracts using Clarity. And again, if you work with Ethereum, you would know we have Remix. People have different Visual Studio Code plugins that they use. Clarity is kind of the way that you would do it if you don't want to use VS Code. You can also use VS Code with a lot of different plugins that they have, and then deploy your smart contracts in that way. But the main reason that they have these different platforms that they use is that this whole process of developing and deploying smart contracts kind of usually requires some amount of UI, or not requires, but it's beneficial for developers. That's why you have this nice UI experience if you're developing with ClarityNet as well, that you would have with the other Ethereum frameworks. It also integrates really nicely with the Stacks JS library. So yeah, that's kind of Clarinet. Okay, next one. Next slide. Yeah, and then you have the Stacks blockchain API, which is a way to interact with the Stacks blockchain. So normally, one of the things that people get really confused by when they look at this blockchain is how do I actually do operations on this blockchain? Because I cannot be, if I'm querying the blockchain, I have to wait for minutes just to get a response, or if I'm doing some writing operations, and how do I kind of like interact and see the transactions that are happening on the blockchain in real time? And for Ethereum, we have Alchemy and Infura that does that. And they're basically just APIs, clients that are storing information and regularly updating what is happening on the blockchain that you can access in real time, so that you don't have to do this whole thing where you kind of make your own solution that looks at the blockchain and calculates the blocks and do all these really expensive operations. And yeah, this is kind of the way the Stacks does it. They have an API that they connect to, lots of sockets that you can connect to in your app, and yeah, that's it. And in relation to Alchemy and Infura, I think Alchemy and Infura are generally free to use, but they have some kind of limit. There's no limit on the Stacks network. You can use it as much as you want. And yeah, for the security concerns, I talked a lot about the security concerns here, but yeah, this graph is kind of showing how much money is actually being stolen from the network. These are just some of the biggest hacks. In general, I think it's more than 3.8 billion that have been stolen the last year. Most of the bigger hacks are related to really easy things that you could solve with an easy audit, like overflow bugs, things where you're not really thinking about the fact that the user can input more than 100 Bitcoin into a minting contract. Like you sell your NFT for 0.1 Ethereum, and you're thinking, okay, the user is going to mint it for 0.1, but then some people figure out, okay, they can send 0.11 and it will overflow the contract and give you more than you put in, for example. These are some of the hacks that are quite simple that people do with Ethereum. Yeah, most of the hacks are on Ethereum in general. And yeah, this is kind of showing the quantity of it. Yeah, next slide. And yeah, so these are I think these are the two biggest hacks that have been on crypto in last year. One of them is Solana based, which is a bridge between Solana and Ethereum that got hacked. And then the other one is Axie Infinity's famous hack, where they lost 625 billion from one exploit, and they didn't figure it out before a couple of weeks later, actually. So yeah, the magnitude of these hacks they're getting more and more severe kind of for each year, and we're seeing more and more money being lost in this way. Next slide. And yeah, now the presentation bit is sort of finished, and we will do a tiny workshop. If you have any questions before the workshop starts, feel free to ask them now and we will answer them. If not, we will do the workshop part.
Okay, yeah, I think we are good to go further. Just share your screen and I will hide mine.
Okay, let's do that. Is my screen visible?
Not yet. Yeah, I see it. So here it is.
Yeah, so this is the entrance point into the kind of Stacks ecosystem for most people. It's Hero Wallet. I think I talked about this one a couple times during my presentation now. It's the same as MetaMask. There's a link in the slides that you go to and you can download it. I've already downloaded it for this workshop. You can click on one of these, download this little extension. It's either a desktop app or it's a Chrome extension. I think most people use the Chrome extension. It's quite easy. And yeah, when you get it, it will appear like this. So you have a wallet where you can see your balances, your activity, receive, send, etc. And if you want to go to testnet, you have to manually change your network. Here I'm changing it to mainnet. And I can go here and change it back to testnet. In order to do this demonstration, you would have to be on testnet because we don't want to be using real stacks. That would be quite expensive. And yeah, so I've received some stacks already from the faucet. The faucet is basically just a way for you to request test tokens from some kind of developer outlet where it will send it to you immediately. So you go to this. There's many different ways of doing it, but the easiest way is to do it from the Explorer sandbox. You go in here, you connect your wallet. Mine is already connected here, as you can see. Here I can see my wallet on the side. And I have one stacks, or I have gotten one stacks at least. I made one transaction using stacks. And I can request some more stacks. And it will say stacks coming your way shortly. And this takes a long time, which is why I have already, or it takes around 10 minutes, which is why I've already done this before. I've topped up my wallet. I have around, I think I have 450 stacks on my account. Or no, I have 500 stacks on my account actually. But yeah, if you want to check how long this takes and what is happening, you can click on this, go to the Explorer, look at your transaction, what is happening. So here you can see I'm getting a transfer of 500 stacks. It's included in the microblock. And if it's included in the microblock, it just means that will most likely be in the next transaction. So I will not have to wait that long. General details about your transaction, the sender address, your recipient address. You can go to these addresses and actually see what is happening in real time. So if I go here, for example, I can click on it and I can see, okay, this address is sending, well, this is a faucet, so it's sending a lot of stacks, different addresses. That's been sending 500 stacks 23 minutes ago, 33 minutes ago. It's like, if you would go into your bank and look at your transactions, but here you can see all the transactions from not only your bank, but everyone else's bank as well, because everything is public in a blockchain. And you can even see the total balance of this wallet. So you can see this stacks wallet that they're sending. It has some, I think it's 4 billion or something like this. It has at least a lot of stacks. Yeah, it's 4 billion stacks in dollars. So yeah, that's the thing. And we have this kind of graphic here that shows me when the next block will occur. So it's occurred 20 minutes ago, 10 minutes ago, 2 minutes ago, etc. It can happen at any time. It's a random distribution. But generally speaking, it takes between 5 to 15 minutes for me. And yeah, but I already have some, so we'll go to the next part of the presentation. And yeah, so if you want to create product or applications in stacks, there's 2 ways to do it. I think I talked about the Clarinet solution earlier today, which if you want to download it, you can go here and search for Clarinet Hero. And you will get this nice UI that you set up locally, and it will integrate, in your local application. You can also install some VS Code extensions, like I mentioned earlier, to build on stacks. Most people prefer to use Clarinet. For this demonstration, I will be using something else. I will be using so this is basically the equivalent of Remix for the Ethereum blockchain, where you develop things in your browser. And Stacks recently launched the same thing, which is called Hero Platform. It's in beta. And yeah, you can create your project, do all the coding, everything is in your browser. And we are going to that. So we're going to create the project first. And you will get this menu where you can pick whatever project you want. You can create your own blank project to do your coding, hello world, non-fungible token NFT, fungible token, order swap, clarity Bitcoin, etc. Lots of different templates to choose from. They even have an NFT marketplace, which I don't really know how good that will work, but yeah. So for this demonstration, we're going to do the NFT, the non-fungible token. So it's going to take a tiny bit of time, and it's going to set it up. So here, if you want to deploy your, as you can see, I'm in the testnet now. But if you want to deploy your contract, you can click here and you can deploy it either to mainnet or testnet. And you can see the status of your contract. My contract failed. I think I tried to deploy this one yesterday, and it has failed for some reason. And if I want to look at why anything has failed this goes for any kind of crypto. It's not only related to the Stacks network, but if I want to see some more deploys on why things fail, what actually happened, I can go in here and check very easily the status and also the source code of what I was trying to deploy. So this is the source code of what I was trying to deploy yesterday. And this is a whole contract for my NFT. I can see the functions for it. Since it wasn't deployed, there's no functions. I can see what block it was on. I can see how much I paid, who deployed it, etc., 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 which I think is kind of cool. And yeah, if we go back here, so I can go and open editor, and I will get this display, this is REPL. It's the same as VS Code, basically. And the first thing you'll notice is that you have this kind of structure where you have a TOML file for some environment variables and some configurations for your project. You have a test folder, which is for your tests. This is a TS file. It's not a clarity file, but it's a TypeScript file. It can also be a JS file. You have some settings. So these are most of the ones. If you pick one of the starter projects, will be some different environment variables for testing. So you can see we have the network. So what network are we using? We're using DevNet. What's the deployment fee? Accounts that you're deploying to, account val wallets. These are mostly for testing. And yeah, it's kind of similar to this file, but this is the environment variables, and this is kind of the test or settings. And then we have the contracts, which is the actual Clarity code itself. So here you will have some different functions that we're implementing, and some different constants, different data types. We have the name of my NFT, so I can go here and change it and change my NFT to have a different name. So I can go Vetle NFT. And yeah, this is a whole contract for just minting NFT. Some of this is using a couple libraries. Well, now it actually gave me a compiler error. I think that was a false positive, but anyways. And yeah, so now it gave me this is like the whole code for just deploying NFT. It's pretty simple. It's not doing that many things. It's not. It's obviously not a complicated NFT. If you would need something that is complicated or generate random traits and does all these things, it doesn't really do this. It just kind of mints an NFT. I don't think there's any picture here. It's just minting a token on the blockchain basically. And yeah, that's the way that works. So, and some of the things that you can do if you want to use, or some things you can do with Clarity is that. So right now my contract, it compiles, everything's fine. I can, change some of these things and make some errors, and it will give me some compiler errors here. Select an assessment name. Now my whole contract will fail. But what I can also do is that if I want to check how this contract would compile, not only in VS Code, but how it would compile when I deployed it, which is a difference. The difference is that when you're doing it internally in VS Code or in some other editor, you're getting the linter errors, but when you're actually deploying it, there's other errors. And since it's declarative and all these has these post deployment checks, we can do some or write a command called clarity net check, and it will check the code for me and how it would compile when I deployed it. So you can see there's one error, which I'm also seeing in the editor because I changed all these different things. And that's how it will deploy basically. So it's the same as the compiler this time. But sometimes you can have errors that your compiler will not see, but when you deploy it, it will be an error or have a security fault, and that's when this will kind of kick in and tell you that this is not something you should be doing, or this is wrong, and it's built in to the language itself. And for the tests file, so we're using TypeScript here, which is the same as you would be doing if you would be developing in Ethereum. You would be testing your code using the TypeScript libraries. We have the Clarinet, which is from something called Denon, which is a runtime. It's basically the same as Node.js, or on the other JavaScript runtime. It depends on what you've been working with, but Node.js is the most used one. And it's basically just contacting or checking with the chain that, hey, I can mint an NFT. I have a function here, and I have my chain. I have my account. Given these accounts, which is in the settings, I can mint an NFT, and that's the whole functionality. So I can run this if I do a command called clarinet test. And it will give me some output. Okay, one of them failed. Oh no, one of them passed. Everything's fine. If I change the code, obviously the test will fail, so I can try to do that just for fun. And we run. And it failed. And if you want to see, so I said you can do this linter check if you want to do the deployment and kind of see how the code compiles, but you also can do something called Clarity Integrate, which you can deploy all your contracts to localized or a Dockerized blockchain setup. And you can also deploy your blockchains before, or your contracts before even deploying into the blockchain, just to see that they work. And it will do this by using the declarative properties basically to check that it can be deployed. It doesn't have to actually use any frameworks. It doesn't have to, you don't have to need hard hat or something outside of the Stacks network. You can just use all the built-in functions, and they're all there for you and good to go. And I think that's it. I don't think there is that much more to show now. Let me see if my transaction is completed for these stacks. No, it's still in progress. It can take some time. So now it's been 12 minutes. So generally speaking, it should be around 10, but this one is a bit delayed. And let's go back to the StreamYard. Okay. I think we can go to the question part now, Alec.
Okay, Vetle, thank you so much. So as for now, we've got one question coming from Vadim Popov, who says, the basic idea of cryptocurrency is decentralization. Doesn't the presence of stacks have the opposite effect, centralization? Do you have an alternative to Hero.wallet and another specific apps?
No, and the thing about this as well is that for Bitcoin itself, there is developers that are developing Bitcoin. It's not a chain that is only there, and there's no interaction of that from the outside world. All these chains all have developers that are developing the blockchains and doing commits to them, and there are changes being done to all of them. So you can like if you want a blockchain that is truly decentralized and doesn't have anything to do with DeFi, then you would need a blockchain that never changes. The best we can have when it comes to decentralized finance are blockchains where you have an open community like DAOs or something like this, and people are committing the code, but it's a democratic process. So there's no one controlling it, but you have people that are kind of voting on things to happen, or people that are approving things to happen by a community. But like the scenario that you are describing, where you have a blockchain, I'm assuming that you have a blockchain where there's no interference from anyone in the outside world. The chain is just running by itself. That doesn't really happen in most of the cryptocurrencies. It's sort of like a scale where you can have true centralization where there's only one entity that controls it, or you can have a more decentralized chain where there's several entities controlling it, or like a community or a DAO or something like this. And there's no alternative. There are alternatives to using Hero Wallet. Like there are other wallets that you can use. Hero is not. It's not like the only wallet that you can use for Stacks, and MetaMask is not the only wallet you can use for Ethereum. There's several alternatives. It's just that Hero is the one that is the best maintained, and that goes for all the tools that I've showed. They don't necessarily. You don't need to use the JS frameworks. You don't need to use any of these specific tools. It just depends on what is being developed on the blockchain. And on Ethereum, you have 100 different ways of doing this. You have 10 different wallets, 10 different JS libraries. Some of them are not as good, well maintained as others. So there's always options.
Yeah. Okay. I think that was the only one question, but let me ask you one question from my side. That will be kind of an abstract question. So, Vetle, imagine you have a magic wand, and imagine you can fix one thing in the world using blockchain. What would be that thing?
I think that's a hard question. I mean, I think the general premise behind them is to have democracy in a population, and the issue that you're seeing a lot of times is that when like power gets really centered around central agencies, like when we have in the 30s we had like people that were controlling basically the whole economy, and they had almost all the money, like this Rockefeller and all this. Like what we see is that when there's too much centralization of power, it's a really bad thing for society as a whole. So I think the thing that I would want to, and I think most people that are interested in cryptocurrency want to kind of solve, is to have a more democratic process in how power and also capital is divided, so that it doesn't get split into this like separate big central entities that are controlling everything. But yeah, like more this was a bit more extra, but what I would like to have right now is just for the governments or different agencies to be able to actually use these cryptos and approve of them, and have some sort of regulation that makes it so the population can use them in an easier way. Because right now it's really hard to be buying crypto. It's kind of, or not buying crypto, but using crypto. There's a lot of regulations that lets you use them easily in some countries and not easier, and really hard in some other countries. So it would be nice to have like a framework for all of them, kind of.
Okay, yeah. Thank you so much for your vision. And I think there are no questions as for now, no new questions. And Vadim says, thanks a lot. Okay, yes. And before we will leave, I'm going to make a couple of new announcements. Just a second, let me share my screen one more time. So, our next event is the Intro to Blockchain for EPAM eKids, which will be hosted by EPAM APAC. So if you have, if your kids speak English and they would like to know about more about intro to crypto, about NFTs, about Web3 and the metaverse, our blockchain lead Sasha Petkevich will be speaking about it tomorrow. Just visit our website and you will get the announcement. That will happen at 12 p.m. Central European Time Zone tomorrow. And I'm going to send you an invitation one more time. Yes, here it is. So, and as I mentioned before, our next big event coming in 2 weeks is the Blockchain Community Day Conference. We already have the agenda set up, and there will be 30 speakers, 5 tracks, and each day will be dedicated to a certain topic. And yeah, once again, visit our website, check out our social media pages. And since there are no new questions, I think it's time to conclude our today's workshop. Vetle, thank you so much for coming, and thank you so much for for uncovering such an interesting topic. I think it's there are not so many content pieces about stacks in the internet, and it's good to have something like this. And we will be speaking about it inside our community maybe sometime later. And thank you once again. Okay, then thank you everyone for coming, and we will see you tomorrow at our eKids EPAM event. Thank you so much. Bye-bye.